So first of all, just apologies for the lack of space. When we talked about doing this, we had absolutely no idea how many people would be interested. And as Phil said, it's the first quality engineering meetup that they've hosted. And so it was an unknown. We didn't expect so much interest, and it's great and really positive and overwhelming that so many people are here. So thank you for coming along. Again, apologies for the lack of pizza, but we'll hopefully sort that after this talk. So my name is Natalie Wood. I'm going to do the first presentation here. So I work at Elsevier. So this is our building. This is not actually part of the Elsevier space down here, but we work on the 3rd floor here, as well as many other offices around. So I'm just going to talk about a couple of things today. The first is just a general overview of the structure that we have in place at ScienceDirect within our team, the strategy that we've put in place to try and deal with some of the issues that we were having and problems we wanted to solve. And there's kind of 2 parts to our presentations. The first bit's about that. The second part, my colleague Russ here, who's one of my team members, is going to talk about a specific issue we have with automation. So we'll cover that at the end. So this is the things I'm going to cover today. So a quick introduction for the company, the group I work in, and myself. A little bit about quality engineering and a brief covering of what the role is, and some common misconceptions about the role. Some hiring challenges and some QE anti-patterns that I've come across in my career. And then we'll talk about the structure we have at ScienceDirect, and then move on to Russ with the current challenges with test automation, which is really about headless browsers versus real browsers. So who are Elsevier? So I've literally gone onto our website and taken what it says there, and then I'll tell you what it really means. So Elsevier provides information and analytics that help institutions and professionals progress science, advance healthcare, and improve performance for the benefit of humanity. So what does that really mean? So Elsevier back in the day, many years ago, were an online, well, they were a publisher. They were a publisher that published journals, print journals that you had physically in your hands, and that moved all online quite some years ago. Now the real shift over the last probably 3 or 4 years is to move more into information analytics and basically be a provider of tools that provide our customers, which are all people in the kind of research space. So they're students, they're scientists, they're professors, people who work at institutions, to allow them to do everything they need to do with their job. So the product that some of us here today work on is a product called ScienceDirect. So I'll tell you a little bit about that. Again, the blurb from the site, Elsevier's leading platform of peer-reviewed scholarly literature. So, essentially, again, back in the day, it was a place where you went to research things of the scientific, mathematical kind of nature. You would generally go there, read an article, perhaps download a PDF and leave. But we're trying, and we're a long way along the journey now in the last 2 or 3 years, to get people really engaged with the articles and talking to other people who are writing articles and finding out who's reading your article that you've published, who's citing it, what are other people reading that are reading the same kind of stuff. So really that's what ScienceDirect is about as a platform. And there's a group here that's been put together. The project started about 3 years ago to basically rewrite this product. So the product's been around for about 20 years. Very clunky platform. Initially it took a couple of years sometimes to get some of the things that the business wanted to do into production. The way we're working today, we're literally putting things into production every day, about 15 to 20 times, so you can have an idea and the next day get something out there. There's a lot more to say about the way we're kind of structured as a team, so I'll focus on the quality engineering side. But I think it's important to say about the way we're working, because it kind of feeds into our structure in that it's very agile, as many places are today, but it's a very continuous delivery kind of environment. To the true term, I've never worked anywhere else where it's been that way, where people have talked about continuous delivery and then delivered every week or two. We're literally 15 to 20 times a day. I mean, it's just constant. So a little bit about me. So I'm the quality engineering manager for ScienceDirect, responsible for the overall strategy, and I have a team. Currently it changes a lot, but it's about 16 people. It grows a lot. So when I started at Elsevier, I was the first FTE to be part of the Elsevier team. So I literally got to grow the team myself, which has been an amazing experience. So we're currently 16. We're going to be growing to about 19 in the next probably 2 to 3 months. I'm also a full-time working mummy of one very sleep-depriving 5-year-old. So if you see him bags under my eyes, it's his fault and not work. So on to what we're going to talk about today. So to start with, I just wanted to talk a little bit about terminology. So the meetup today is called a QA meetup, but this is something that's very close to my heart, and perhaps I feel more passionate about it than than I should, but the terminology of quality engineering rather than QA for me is really, really important. So I wanted to talk a little bit about that, about for me, the kind of misconceptions that people have, and the connotation that the term QA has, just because it's been around for so long, and the role as it was is very, very different now, and it's really changed into a role where you have to be an engineer to do it in some form, and you're looking at the quality, and the quality engineering is for me, in terms of an employer and an employee, really important to think about ourselves in that community in that term, because the world has changed and we need to keep up with the way that the QE space is changing, as well as any other part of technology. So this is from Wikipedia. So the quality engineering is the management, development, operation and maintenance of IT systems and enterprise architectures with a high quality standard. So I think everybody will probably agree that quality is owned by everybody, but quality engineers, who are called QEs rather than QAs, are responsible for championing this and making sure that the team is considering quality from the outset. So that's my take on what quality engineering is really all about. So some things about what it's not about. So quality engineering for me is not just about testing, it's not just about test automation, and it's not just about finding bugs. They're all parts of it, but it's not just about those things. So what it is about, this is not an exhaustive list, this is just a whole load of things that cover the majority of the things that we're covering in ScienceDirect and Elsevier, and my feelings about what the role is about. So it's about asking questions, clarifying and helping to define requirements. It's about thinking about the system from a user's perspective. It's about ensuring that we have appropriate automated tests at all of the levels before you release to production, and then cover those issues early on. It's about exploratory testing, and that's testing with a purpose and not just randomly clicking on things. It's about ensuring we've got appropriate measures that are in place to find any bugs that slip through to production straight away, so we can just roll back before the users find them, and do that without any system downtime. And we do that by having things like appropriate alerting and monitoring dashboards in place. So just some other kind of general areas that we cover with quality engineering, and it's about thinking about all of these things from the outset. And again, this isn't an exhaustive list, but this is a list of things that we focus on particularly in the area for our product, because they're important for the kind of product that we have. So compatibility, performance, security, and accessibility. So the quality engineers, they're the guardians of quality, and I've got a little picture of my team just here. Which one are you, Russ? Are you the muscly guy on the? Yes. I thought so. Okay, so a little bit about hiring challenges in QE anti-patterns that I've come across. So there's a huge amount of stuff that quality engineers need to do, huge amount of stuff. And a lot of stuff I think that people don't appreciate all of the things that we have to do. So how do you make sure that you cover that in all of your teams? So if you imagine, many places today are working in cross-functional team environments where you've got however many teams you need to do what you need to do. How do you make sure that you are covering all of those things with one person in each team perhaps, or a couple of people? So some anti-patterns that I've come across are having no QEs at all. And I've worked in a couple of places where that's been there always, and places where they've got rid of the QA team, as they've called it. And some places where they've started up a business and haven't thought they needed them. And one of the reasons that they think they don't need them is they say things like, well, we've just get developers to write the automated test. Why would we need anybody else to do anything? And my point is that just covers that as one small aspect of quality engineering. There's a whole load of other stuff. So who's going to do that stuff? So having a central test team, I think a lot of companies are moving away from this, but for me, it just doesn't work in an agile environment. It doesn't allow you to have people embedded in the teams that can work with the developers, understand the product, understand the area, and think about quality from the beginning. You can only do it after the fact if you have a central test team. And the other thing I've come across, which is probably the more common one that I've come across recently, is trying to hire embedded team quality engineers that have all of those skills. So they are performance experts, they're security specialists, they're automation specialists, they're the right kind of personality to ask questions and define requirements as well. So the reality, from my experience, is that nobody has all of those skills. I've never met anyone that has all of those skills. So I've come across people who have a lot of those skills, but they're really rare, they're really hard to find, and they're really hard to hire. And if you can find them, and you can hire them, and you can take all that time, they're really, really expensive. And even if you have the time and you have the money, and you hire those people, it doesn't allow movement in your team, it doesn't allow for mentoring, it doesn't allow for a sort of healthy balance of juniors to principal level type quality engineers, which for me is really important to get that balance in the team. So the solution that we've come up with, and I've got a little asterisk here because it's important to say it's not the only solution, it's just one that we've come up with, and it's adapted over time. So it was kind of a vision I had when I started to put the team together that we've changed a little bit and tweaked to fit things that we've tried that haven't worked so well, things that are working really well. So the way we've tried to cope with how do you cover all of those things, so we've hired a team, we've hired embedded team quality engineers. So each of the teams that we have, so we have around maybe 8 or 9 teams right now, cross-functional teams. So we have at least one quality engineer in each of those teams that has the right personality, and for me that's far more important than anything else. Some of the skills, as many as you can find, but a clear ability and a passion to learn new skills. So we've hired a small team of experienced specialists to work with teams to cover some of the niche areas, and I'll show you on the next diagram which of those areas we've focused on. And the other key thing is that the embedded quality engineers learn at least one additional skill set. So they all of my team have an objective over the year, and they all want to do this, to learn a specialist skill and to share that with the rest of the team. So not just to learn it and be isolated within your team. Part of that knowledge, part of the goal of that knowledge learning is to share it with everybody else and cross-train. So this is just a really, really simplistic picture of the structure. So again, these are kind of the cross-functional teams. There's many more than here. This is just to fit it on a slide, but there's cross-functional team. There's a whole load of developers in there, and perhaps a business analyst, product manager, UX, whatever you need to make that team work. And then within that, there's at least one quality engineer. Sometimes there's more. So that's the green box at the bottom. So those individuals in those teams are responsible for all of the quality aspects. So it's their job to make sure that those things happen, but it's not necessarily their job to make sure that they have all of the skills within themselves to be able to do that. But they need to be responsible for making sure that they engage with the people at the right times who can do those things. So outside of that, we have a couple of sort of shared cross-team groups of people. So we have 2 real groups that we focus on hiring within our SD technologies, what we call ourselves, the ScienceDirect technology group. So we've got a small team of performance engineers. We've got, for the 16 quality engineers we have, we've got 2 of those. We probably could do with 1 more. And we've got a small team of automation specialists, of which Russ is one, who's going to talk about the automation side shortly. And we've got currently 3 automation specialists, which is about the right number. Again, possibly could do with another one. Now, the way that this works is that, say, the quality engineers are responsible for the quality, for everything that happens in that team, but they engage with these cross-team folk when they need to. But the really important thing is they don't just engage and hand the work over the fence. They don't just bring in a performance engineer and say, we need to do some performance testing, do it, and then give us the results. They work with them and they pair with them and they learn how to do some of the aspects of that role themselves. They're unlikely to ever become performance engineers of the standard that these guys, the people we've hired at the top here, these are the expensive people who've got 10, 15 years experience in their field. Some of them are contractors because it's really hard to find those people that are willing to be FTEs. And then the automation specialist, again, same thing. We've tried a couple of models with this. So we've tried a model where the quality engineers within the teams are assigned an automation specialist and they go to that individual, and that worked really well in the kind of pairing and upskilling point of view, but what it didn't allow for is any of the cross-team tasks to be done as well. And it also didn't allow for the automation specialist to be there at the beginning to think about other ways that we can automate things that perhaps these quality engineers here at the bottom are not aware of. So probably important to say that this mix at the bottom here, this is a real mix of levels and skills. So we've got some graduates, we've got some people who've transferred into technology for the first time, who've never worked in technology before. We've got right up to principal level. So you can hire those people at that level and support them by these specialists, just a smaller number of specialists at the top there. So outside of those groups that we've hired within our team, there's also some specialists that work within Elsevier, but not specifically for our products. So we've got some security specialists and actually just one real accessibility specialist for the whole of Elsevier. And Elsevier's got a technology group of a lot of people. It's over 1,000. That are based in all sorts of different locations. So for example, we have an accessibility expert that's based in the States, and he's one guy and he covers all of the accessibility requirements for Elsevier. So that's great. We can lean on him and use him as a consultant, but that's not going to bring that in-house and allow us to think about it from the beginning. So So the whole piece about having an additional skill to learn. So we've got these specialists that we've hired, and then each of these embedded QEs, they have to pick something that they want to focus on for the year. So the three things that we focus on are compatibility, accessibility, and security. And I've tried to encourage people to do it in a way where all of those things are covered. So we've got all of those things covered within the team. And we're doing that by, a combination of sort of training and, internal training, external training, courses, in their own time, and then pairing with some of these specialists that we've got and bringing themselves up to speed. And then we share that. We share that by working sessions or just pairing with other teams when they need to conduct some of that work. So just to reiterate some of the key points about the structures, the embedded quality engineers are responsible for ensuring all of the aspects are considered, but they're not necessarily having to do it themselves. The automation specialists and performance engineers, they are shared across the teams, but they don't sit outside of the team. So when a piece of work comes up that requires their specialist skill, they sit inside the teams. And they don't just work with the QEs either. They work with the developers. They work with anyone in the team that needs that support. And that allows them to spread the best practice and to have some levels of consistency where you want it, which you don't necessarily want in all aspects. And then all of the embedded QEs select at least one additional skill to focus on, and they spread the knowledge. So that's it at a really, really high level. There's a lot more to say about that, but this has grown over the last, I don't know, 2 years now, 2.5 years into this team of about 16. And one of the things I wanted to say in terms of sort of scaling this, because this has been quite easy for me to do because I've grown a team from nothing. So it's a luxurious position that not many of us are in, and I've also got a very big team, so it allows me to hire these specialists. And I tried to think about what kind of questions people would ask about, how does this work if you've got a tiny team? So this model scales down to at least half the size of this, because you could have just one performance engineer and one or two automation specialists, and just have eight embedded team QEs. But when you're getting really small, it's difficult then, and I don't know what the answer is. So if you're in a new startup and you've got, you start with one team and you want to hire one QE, it's difficult, and you have to try and think about how can we bring those skills in from other areas. So how do we get a developer to focus on some security testing, or how do we get them to focus on performance engineering? Because somehow you're going to have to find a way to spread those skills around. No one person's going to do all of those things for you. But yeah, I don't have the answer to how you start from a really tiny team. But once you get to the size of about 6 to 8 QEs in your team, then this works. And it's worked really well for us. So really today, what I wanted to do was just share that with you all, because when I started the team and did some Googling about, how can I put this team together and cover these things, there wasn't really anything else like this out there, and I haven't come across it. So what it's allowed me to do is hire really great people with great personalities that don't already have these skills, and train them and support them so they're never under stress. They don't sit in a team and suddenly get told you have to do all of these things that you can't do. They have to make sure it happens, but they don't have to know how to do it straight away, and they can learn in a kind of relaxed environment. So as I say, that's it in a nutshell. I've got my email address here. I'm presuming these slides will be sent out afterwards. There's a box of business cards at the back if anyone wants to ask me questions after today. So my email address and everything's on there. So please feel free to do that. And I need to remember to say that although today was about sharing this, we are hiring. So please do contact me afterwards if you're interested in coming to work for us or hearing more about what we do in more detail. So with that, I'm going to hand you over to Russ Huber, who's one of the automation specialists in my team. So he's going to cover some challenges we've come across lately to do with headless browsers versus real browsers for our automation. So we've got a presentation on Prezi that hopefully will work. And
I'm going to be really quick. I'm aware that pizza is, you guys are all waiting for that. But what I want to do is just introduce you guys, and we've hit some problems, particularly in the area of UI automation for a web application. So I want to share some thoughts about what we've encountered and the solution that we've chosen to sort of take us through that pain point. Setting a bit of a background on headless browser technologies. I'm sure you guys have all worked with them before. There is a plethora of tools and utilities out there to allow scripting of a web browser without the overhead of the physical UI. There's a number of them available, built on known browser engines, and people will typically pick them up for the reasons of speed and efficiency. There is no need in using full browsers if you don't need to. Phantom.js is one of those tools. First released in January 2011, so it's 6 years old, and it received an update in 2015. Even with this update though, it only brought it up to the standard of an equivalent of a Safari 2014. So it was sort of brought up to Qt 5.3. It is a popular tool, but it does have its shortcomings. But as of April 2017, this guy in the bottom corner made a rather significant announcement that he is no longer continuing with the evolution of this tool. Based on the announcement of Headless Chrome. Phantom.js happens to be the tool that we use, and it left us with a bit of a problem. So we looked into this Headless Chrome and we thought, right, what does this do for us? Well, it's kind of brand new on the market. Released in Chrome 59 back in May. We integrated this into our regression suite and found that it was only about 5% success rate. Essentially, the Chrome driver hadn't rolled forward enough to the point where it was compatible with the new Headless Chrome, and we had a lot of problems. Needless to say, it was too early for us to pick up. Here's a bit of a diagram of what we expect it to be. So obviously Phantom.js, our pack was starting to decay away, and Headless Chrome was still kind of bringing itself up to feature parity with Phantom. And we are somewhere in this box here, whereby Phantom.js is still kind of working for us, but we're seeing atrophy. But Headless Chrome is still a little bit on the horizon for us. That was where our problem was. We looked at integrating virtual displays by using headed Chrome with virtual frame buffer. And we managed to integrate this successfully with reliable results. So this was a real success. However, because our pipelines all run in AWS in the cloud, and given the number of cores and and because of the instance size it takes to run them, it was simply too expensive for us to be able to put that up into our pipeline. So it led us to look at other ways of solving this problem. We started looking at Selenium Grid. Does anyone not know what Selenium Grid is? Right. Selenium Grid is essentially a way of distributing your test execution across a number of nodes that have various different configurations of OS and browser technologies deployed. You send your test to a hub which knows how many nodes it's got in its swarm, and the tests get delegated out to those parts. There's many ways that you can configure Selenium Grid. We first looked at using local hardware to achieve this. But the problem we ran into is our pipelines were configured with GoCD, which is a cloud-based continuous delivery system. Our platform guys pushed back on having trust boundaries established with local hardware internal to our office. So this was really a no-no for us. We looked at pushing that Selenium Grid up into the cloud. AWS is in the cloud, our pipelines are in the cloud. We needed to sit them alongside each other. So we tried to use a combination of Docker, Compose, oops.
I think it's when you step on it.
Try not to do that then. Can't believe you managed to get through all of yours. So we tried using Docker Compose mixed with Selenium Docker. There's a number of Docker images with Selenium Grid capability that are readily accessible as part of Selenium Docker. And if we was looking for a long-term solution, this would probably be the way that we would go. It's scalable, it's maintainable, it gives you an option of tearing or building tear-down grid infrastructure in order to use Selenium Grid in that way. But this required a lot of support from our platform team, and they were super busy. We only needed this to fill a short-term goal until Headless Chrome became sensible for us to pick up. So it kind of counted it out for our needs. And so we came across this Gridlastic. It's a managed cloud-based solution for a Selenium Grid. It ticked all the right boxes. It had auto-scaling. It allowed us to launch the grid in the same AWS region as where our virtual private cloud existed in, giving us speed improvements and reliability. It ticked all of our boxes. So we had a bit of a go at integrating. When you sign up to Selenium Grid, you get a rather straightforward dashboard, many configuration parameters that you can configure according to whatever needs you've got. We set this up, we press the Launch Grid button, and you get given some URLs, some credentials in order to instantiate your WebDriver instance. When you instantiate your WebDriver instance with these credentials that Grid provide, your tests are going to be directed towards that hub, and your executions are going to happen in the cloud, on the grid. When we integrated this, what we first saw was a noticeable increase in how long our regression pack took to execute, for the simple reason that when we're forcing tests into the cloud, we've got that extra hoop that we have to jump into. And we've also got the overhead of a real browser. We needed to get that down. So we started to look at how to parallelize the suite that we've got. And with Java and Groovy, our infrastructure, we use Gradle for our build tool. And gparse is a nice tool that allows you to set up a pool of threads in order to set up your executions to run within. It's open source, it's easily integrated, and it allowed us to parallelize based on our own requirements. Of course, whenever you're talking about UI-based tests, you've got things like network lag to consider. You can expect the odd flake, particularly when you're running a regression suite of about 400 tests. We needed to implement rerun. How many of you guys don't have rerun with your UI stuff? Oh, you. Maybe you should. It's a good thing. So we did. And what that means is when you're separating out that execution, you'll get an individual report file for each thread. And therefore, there's a process that you need to do to knit together the executions of each of those threads in order to form you one main report. So we had to do a little bit of work on aggregating the reports, and we managed to do that successfully, and we ended up getting some nice reports out of it, which would give us some extra information that we was hoping to get. So with that integrated, what is the concluding part? Well, we managed to shrink the execution time from 20 minutes with Phantom down to just over 12. So with that parallel execution, even though we're forcing it into the cloud and using headed browsers, we did get that down to a significant improvement, which was of course workable for us. And this is going to tie us through that pain point until Headless Chrome reaches the point where it's ready for us to pick up and start investigating headless technology again in our packs. Just to cover a few benefits of what we found with Gridlastic. We found it easy to configure, easy to integrate. There is a pre-launch API that allows you to configure the grid infrastructure itself, the swarm of nodes, what browsers you are using on those nodes, and that's all highly accessible and highly configurable. It is scalable, given a few caveats that we'll come on to on this side, and it's very customizable. So to be fair, as I mentioned just now, this was definitely a workable solution for us for the short to intermediate term. Obviously, we've got to provide a balance point, so I had to put a few shortcomings up here. There is a confusing price structure to it. It's all based on instance size versus how many credits you use for parallelization and stuff. So, you know, you've got to have a maths degree to understand it. There is no OS X environment on this yet. It's coming, but it's not there yet. We can get away with it for the time, but that would be nice. And there is no device or emulator option. So if you're looking to kind of use Gridlastic or use a Selenium grid solution to do the same thing that you might use BrowserStack for, currently it's still not quite there in terms of features. But it's taken us through a bit of a pain point, and I would certainly recommend any people that are, or any of you engineers, any of you automation guys that are looking at this kind of stuff and still not finding a solution to that problem. Hopefully I've provided a few interesting points here for you to consider.
So I think it's probably worth saying that the Gridlastic has nothing to do with our company whatsoever, so we're not selling that for any personal gain. It's when we were looking for this kind of thing, it was the only thing we could find on the market that did that exact thing.
Yeah.
You know, maybe there's others since we started looking a couple of months ago, but it was the only thing like that, and yeah, it's worked really well for us.
Are we doing questions?
I think we're going to do questions after. We're hungry. There's pizza outside waiting for us.
Thank you for your time.
Natalie, thanks very much.